Hello, everyone, and welcome to today's SANS webcast, ICS Cyber Resilience, Active Defense and Safety, Part 3. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dean Parsons and Stephen Mathiser. Both are SANS certified instructors. If during the webcast you have any questions for our presenters, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Awesome. Carol, thank you so much. Hello, everybody. Thanks for joining us for part 3 of this webcast series. So if you have not attended our prior webcast series, myself and Stephen are going to do a quick introduction. I'll go first and I'll hand it over to Stephen. So welcome. I'm Dean Parsons. I am a certified instructor with SANS. I teach the ICS 515, the newly updated course for ICS incident response and visibility detection and response. I'm also a co-author for the new upcoming ICS 418 class. It's the ICS Security Essentials for Managers as well. Very, very short introduction, 20 years experience in IT, the last 10 specifically in the OT and ICS space across electricity, generation, transmission, distribution, power facilities, SCADA control systems for power, but also in oil and gas as well. So refineries, marine terminals, and storage and distribution as well. So also assessments in other types of ICS installations as well. So glad to have you guys here. With me as lately for this webcast series is Stephen. So my partner in crime, I'll pass it over to him.
Thanks, Dean. Welcome, everyone. I'm also a SANS certified instructor. I teach the ICS 410 SCADA Security Essentials class. I've been in IT for I don't know, 25 years, something like that. Security for the last 20. And I spent a long time in the oil and gas industry myself. Doing all sorts of things, security and ICS, and now consulting with, from the other side with customers more or less in the same industry and helping them out with their ICS security.
Awesome. All right. So just to kind of level set where we are in this series, what we've been doing in this series, and this is number 3 of that. We have a couple left to go. In this series, we're talking about things like fundamental ICS security concepts. Things like recent events in ICS, so ransomware impacting critical infrastructure, a variety of defense, of course, as well, threats and defenses. And really the end of each session that we have is minimum kind of defense takeaways to mature your ICS security program. Also, there's free resources that we kind of toss in there as much as we can as well as we go through. So for this session, we're going to talk about a couple different things with regards to active cyber defense. But just to recap part 2, we've done a couple different things in the last webcast, really talking about security control placement inside the ICS. So if you were for the last session, Stephen really focused on things like architecture and where inside the industrial environment you put things like your jump hosts for remote access, update servers for patching, things of this nature, file transfers in and out of the ICS where needed, but really also the Active Directory infrastructure for authentication being a completely separate Active Directory infrastructure than in IT. Moved on, we talked about patching as well, and the crux of that conversation is really about patching smartly. We want to make sure safety is still number 1, so CVSS scores is not the full story, especially in ICS where you have to consider safety. And of course, we are seeing adversaries really focus on abusing industrial control systems. So there could be a vulnerability that even if you patch it, there is still a risk there with an adversary abusing an HMI as an example. So CVSS scores not the full story. And then we talked a little bit about logging, and we'll talk about logging again today in a way of getting data to do threat detection. So we talked about a SIEM as well. We talked about having an IT, an OT, a separate SOC, and also a converged SOC in their last session, which was part 2. For this session, part 3 today, we're going to walk through examples of the active cyber defense cycle. So we'll talk about threat intelligence and how each one of these areas feeds into the next, really kind of building your cycle and then looping back around in this repetitive cycle that must have human kind of defenders using technology to do really advanced defense, which most ICSs or all ICSs should have today some element of active cyber defense cycle in there. So where are we? We did cover the sliding scale of cybersecurity, and we talked about architecture, and obviously then pivoted to active defense, which is really we're gonna be talking about today. So what you have to take away from this slide is architecture, then passive defense, again, builds together to active defense. Now you might say, well, what is active defense? And there's a whole bunch of different kind of terms out there for active defense, and some of them are I'll say, not so accurate. What active defense is really the idea and process of repeating the monitoring and responding to events in your environment inside the ICS, learning from those threats. So applying threat intelligence, getting visibility inside the industrial control environment at the plant level, and then understanding when it is appropriate to do incident response, prioritizing safety, and then pivoting over to reduce the impact, obviously, to the environment, but also change the threat that you find in the environment as well, and kind of pivoting around there. What active defense requires is humans, defenders, using the technology, leveraging threat intelligence, leveraging tools to hunt for threats and signs of intrusions, as an example, and helping automate that wherever you can. And then, of course, humans interacting, in this case, ICS security folks interacting with engineers to do incident response, and then pivoting to prioritize, yet again, the safety and reliability of operations. So we're going to get into each one of the steps of active cyber defense in a moment. What ACDC, rock on, active cyber defense is not, it is not hack back. We'll talk about the different phases in ACDC, and none of them are about hacking back, but it's really more about being active and agile in your network, being able to pivot in your environment to do actual defense and execute ICS specific incident response. So if we take a look at the active cyber defense cycle, here's what we have, these specific 5 different components of this cycle that continues. Again, as you see on screen, it's the repeated kind of process and actions monitoring and responding to learning from the adversaries and threats internal to your environment. So they will encompass things like getting threat intelligence. And I know someone already is like saying, so we get threat intelligence today. It's our vendor security advisories. We'll have the discussion about what the difference is between that and also specific threat intelligence. So we'll consume threat intelligence. We're going to do visibility, which is getting as much information about the assets that you have in the environment, and also the information about the logs in the environment as well. And then you're able to then do threat hunting, or really threat detection. And then, of course, when you look, you will find things with incident response. You're having to pivot to doing incident response based on some determination you have when you see events inside the industrial environment. And the last piece of this cycle, which continues back up to threat intelligence consumption, is the threat environment manipulation. So we're going to step through each one of these phases. We're going to really describe what they are, where to get some of the tools and some of the techniques to kind of put this inside your ICS environment. But also we have, a lot of questions that we're going to help answer throughout this entire session today. So myself and Stephen, we're going to go back and forth, just kind of asking questions and answering questions for each phase of the active cyber defense cycle. Now, before I pass it over to Stephen, what I'm going to do is really break down what threat intelligence is. And if you are on a budget, then here is really how to start leveraging threat intelligence, or at least some indicators. As we'll talk about, there is a difference in indicators and TTPs, but in general, this slide really represents freely available information and threat intelligence from various sources that you can use to guide your active cyber defense cycle for the protection of your ICS. So if we start at the top, we can take a look that the SANS Internet Storm Center has a lot of data and intelligence there. Not specific to ICS all the time, but it's a great place to start, again, on a budget. And as you go down through, you'll see other resources here as well. If you're in critical infrastructure in the electric sector, for example, the electric ISAC or the e-ISAC is available for you to partnership with them and get a membership to get intelligence specifically from the threats seen in the electric sector. Now that's going to be critical, right? Getting specific threat intelligence for your sector. The same with oil and gas, and there's other types of different sources out there as well. If you're in Canada, The Canadian Centre for Cybersecurity also has alerts, and they do include industrial control systems as well in there. So these different sources can be available to you, and each source can give you different information, such as an overall high-level view of a threat that's in your sector, but also a lot of them now are more and more are including things like the IOCs, indicators of compromise, the tradecraft of the adversary as well, TTPs, but also things like YARA rules and technical ways to do detection in your environment based on what the threats they've been seeing in the sector. And of course, I want to just put a plug in there for the MITRE ATT&CK framework for ICS as well. So if you are familiar with MITRE ATT&CK, there is a specific one for ICS tailored to our industry and tailored to the devices and engineering devices, but also the attacks seen in the ICS environment. So threat intelligence in a nutshell, there's where you can get some information to kind of start your team up. Now, what is threat intelligence, you might ask? The first thing we want to do is really identify what is a threat. A threat is really an actor or threat group with intent plus the capability to cause harm plus an opportunity. So you don't have a threat if you have a vulnerability as an example, but there's no way to exploit that vulnerability. So this idea that a threat is really a threat actor with a capability and an opportunity to cause harm can really help do things like prioritize patching, as we talked about last time. Threat intelligence comes from various different sources. So what I do want to try to introduce you to is the life cycle for threat intelligence. And as we kind of go through here, you'll kind of see that out the other end is you're going to get a refined version, which is threat intelligence that you can apply. Threat intelligence can really be applicable for you to cause action in your team, to scope an environment looking for threats, or to not action anything as well. So it's really important to understand what assets you have in the environment as well. So in general, threat intelligence can help you action things or really realize that there's no action, continue moving on to something else in your environment kind of thing. So overall, you're going to see that raw data, sensor information from the internet, sensor information from organizations inside the networks, all of that raw data is picked up and sensed, and that creates a whole bunch of information. But that information is not going to tell you what's actually happening because it does not have context. So the raw data is really creating a lot of information. The information is then processed and kind of exploited to create the information plus context, which gives you that threat intelligence. So as an example, if you have a honeypot on the internet and someone scans port 502, that does not mean that there's someone targeting industrial control systems, because 502 is a Modbus TCP port. With the context though, if it's specific only to Modbus TCP ports or similar types of ports, then that could be different. So that context is required. Quickly, you're seeing now at this point that context requires humans in the loop in threat intelligence to consume the information, apply the context to give us threat intelligence. So you probably have a lot of questions about threat intelligence as the first phase of active cyber defense. So what I'm going to do is I'm going to pass it to Stephen to answer some of these questions. And some of these questions you probably already have. And as a reminder, if you don't see some of your questions answered in this deck as we go through, please place them in the comment section so we can actually take a look there and address your questions at the end in the Q&A. So I'll pass this over to Stephen for threat intelligence FAQs.
All right, thanks, Dean. So I guess I will start with the media, because who doesn't love the media today? It's we trust all of the information we get from media of all sorts, right? Including the threat intel that the media can provide. So my take is really simple. The goal with threat intelligence is to get complete information, accurate information, relevant information, and timely information. Without slagging the media too badly here, I would suggest that none of those things is true with what you're getting from the media. The media is probably not the last to know, but not the first to know. It appeals to a broad audience. That's not necessarily relevant to you. You can't deal with every threat against every person or industry or company out there. Accurate? Well, yeah, maybe not. It's a bit of a crapshoot. And complete. You never get the full story. So I think we started you off with a softball question there. I think the answer is generally no, or it's a very last resort. More interesting, or maybe not more interesting, but more relevant, IOCs and TTPs. We see these acronyms all over the place. What are they? How do we use them? An IOC is an indicator of compromise. And in my head anyways, this is technical data. These are very precise indicators like IP addresses, like file names, like file hashes, websites, URLs. They are technical data that you could put into something like a SIM and use that to correlate logs. You could hunt for these kinds of things for IOCs at a technical level with something like Yara. They're typically host-based or network-based. So again, the host-based are the things like the files, the processes, the hashes. Network would be more like IP address, DNS, URL, host name. So I think you can figure out maybe where you would start to collect that information, and you would tend to use that in some sort of automated fashion, right? It gives us data and context to go investigating, hunting, and so on for our adversaries. It may not be our primary detection method, but it helps us scope IR. It helps us focus on what we're doing when we're trying to get an adversary out of our environment. Whereas TTPs, to me, are more about what is the person or the adversary doing who's behind an attack, and how are they operating. So I don't know that I would say it's about human characteristics, but it's about the things that the human or the group, or it could be automation, I suppose, are doing. So what are the impacts? How does it manifest? What do I see? And honestly, TTP should allow you to prepare in advance. You should know, well, these are the kinds of things that the bad guys are doing, so I can put my defenses in place in anticipation of that, especially if I know that those TTPs are relevant to me, back to the relevant piece of threat intel. And of course, I could use it to identify attackers in my environment. I've talked a little bit about sector specific already, right? Relevant. Again, there's so much information out there. Sector specific intel is much, much more valuable. That's where I want to start. That's prioritized for me. Gartner, I think this is Gartner, defines threat intel as analyzed information that fulfills a requirement. So I need to know why I want the threat intel in the first place. Analyzed information that fulfills a requirement related to adversaries that have the intent, capability, and opportunity, as Dean said, to do harm to you. So the two key phrases or words in that statement are requirement and you. So I have requirements to protect certain things that are of value to me, and I want to know about things that are threats to me. And finally, on the processing side, start by knowing those requirements. Start with the planning so that you can turn it into relevant information. After you've planned, you need to get the information, the TTPs, the IOCs, you need to put them in a format that you can consume, then analyze them and filter that down to meet your requirements, and then make it digestible and share it. It can be partially automated for IOCs, but humans need to be involved as well, right? Again, only those IOCs are really processable at a technical level. The rest requires people to look at it, disseminate it, maybe write some reports and share that information about what's going on. And awesome. We could go on, but it's time to move on to other topics.
It's great how you mentioned TTPs, or like, you can get ahead of it. It's the advanced kind of thing you can do. It's proactive security, whereas IOCs is really that scoping, could be a one-time thing. Now, from a practical perspective, and Steve kind of mentioned this, like the critical assets that you're going to want to scope on your endpoints, scope in the network, is really around those critical, top 4 or 5 assets in the ICS. So network communications to and from your HMI, your PLC rack as an example, your historian, and the engineering workstation. I mean, starting there is a huge return of investment, because you're directly first initially protecting your critical assets in ICS. So great place to start. And as Stephen mentioned as well, you have to have people in the threat intelligence lifecycle, refining and adding context. But in active cyber defense, in the cycle we're talking about, you cannot just click a button and let some automated system kind of do it. Use automation where you can, but you'll ultimately have to have people, an FTE here, for example. The next piece is really the visibility aspect. So leveraging the threat intelligence. If you don't have visibility, like Steve mentioned, you cannot use the IOCs. If you don't have the network information, you can't check to see if you've been compromised. And if you have no visibility, you really have no way to understand how to apply proactive defense for using the TTPs. So one way is really to get the visibility on the network and on the endpoint. If you had one place to start, and Stephen, jump in anytime, I'd really recommend focusing on the network first, so network security monitoring. So obtaining ICS network visibility, you have two options with regards to getting that information from the network. We're going to do a deep dive on this later, and Stephen's probably going to run down through some pros and cons maybe on switch versus a tap. And of course, you can do a span port on a switch to get you the traffic from your network. And there's pros and cons to that, but you can also have a tap in the network as well to get that visibility, right? The ICS network visibility. Now, if you're thinking, okay, that's a lot of data, you have two options. One, a full packet capture, which is everything in the packet, the full streams with the payload. Huge advantages because you're getting things like malware samples inside the PCAPs that could be flying around your ICS as an example. But if you are concerned when you start off network security monitoring and visibility, the 5-tuple is a great place to start. I always get these questions, right? Well, if we can't do full packet capture, well, what's the value? There's a ton of value getting just the 5-tuple if that's where you want to start, which is your source IP address, destination IP address, source port, destination port, and protocol. Huge value because quickly just looking at the network behavior, you can quickly see things like spikes in the traffic and also things like valleys in the traffic. So these behavioral changes in the network can really draw attention to evil inside the ICS. Now, there's several benefits to network security monitoring and visibility in the ICS looking at the network. What's important here, though, is you really want to go as deep as you can to get things like the communications at the lower levels of the Purdue. So anything from level 0 to level 2, as an example, all the sensors, controller communication, and then up from 2 to 3, you really want to get the HMI communications to the field and back as well. Critical. Also your engineering workstation, those critical assets, right? That communications is really essential to get that visibility. So if you only roll to your site and you only get visibility at level 3.5 in the DMZ, that's okay, but it's not amazing because the adversary may come through there, may not. So getting visibility on the plant floor is really where we're trying to get industrial control systems in critical infrastructure to go, because that's where the adversary is. So getting visibility at the plant floor. I've had this question as well, from the engineering staff. Awesome, heard you guys are putting new equipment in the ICS. That's awesome. How's it going to affect the generating station? How's it going to affect the substation? Well, actually, it's going to be, detection capabilities, but it's also an ability to check and help out the engineering team as well for troubleshooting. I mean, I can't tell you how many times we've deployed sensors in a passive way inside substations and refineries that say, hey, we've been trying to track and troubleshoot something from an engineering perspective for months, and you guys now have packet captures. Can you help? Absolutely. By the way, we've just seen that your HMI is trying to send something to a meter in the field using a protocol that the endpoint doesn't understand. So that's probably where the issue is. Here's the PCAP. So a lot of value from a security perspective, but a lot of value as well with engineering and kind of helping troubleshoot. So you can quickly see these teams kind of shaking hands, working together for your incident response later on, right? Making those really strong kind of relationships. Beyond that, when you get network visibility, the payload version, the full PCAP, you're going to get malware samples. That's going to be critical to doing triage when we talk about that later on. Now we're focusing mostly on the network at this point, but we can do things like get forensics data from endpoints as well. But again, my suggestion, if you're starting somewhere with network visibility, with ICS visibility, start with the network first. Now, also when you do get network visibility, you're going to want to take a look at doing the asset identification for your environment. Now, very quickly, there's 4 methodologies to get ICS visibility, your asset information and inventory created. Of course, there are physical inspection, getting to site, talking with the engineers, and kind of literally with a laptop, encrypted laptop, with something as simple as like a spreadsheet application and going around literally, tracking what's in each rack, what PLCs are in the rack, what protection control devices in the rack, what RTUs do I have out here. All of those things logged into a database is going to be critical for you to understand what your risk surface is when you get threat intelligence. So now we're seeing things like threat intelligence from the first phase feed into visibility. When you get an asset inventory and threat intelligence combined, you can quickly determine, oh, wow, there's something out there. It's called Trices. It's targeting Triconics controllers. Wait a second, we don't have any. Cool, we're not vulnerable yet at this point. Still important to understand what Trices is because it can be scalable, potentially. Crash override is scalable, unlike Trices, but at least you initially know that you don't have any risk at this particular point or no threat active in your particular environment. So getting to site is that physical inspection. A lot of different pros and cons to that. It's time consuming. There is some risk to it, but it's really it's physical risk. So you have to have protective equipment when you go to site. Now, the second one is the passive network traffic analysis. And that's really safer for the ICS environment because you are not injecting anything in the environment to understand what assets are there. You're looking at the actual traffic and sniffing the traffic passively to understand what assets are communicating and what's actually in the environment. Configuration file analysis is up on the top right. There's some risk to that. You have to touch a lot of different devices to get configuration file analysis. So yes, it is logging into devices, getting like ARP table output, getting all of those information and kind of piecing it together. So there's time consumption for that as well, but you may miss things. For example, you hit a firewall, maybe you're not down deep enough in the ICS to get information about assets communicating below there, your east-west traffic versus your north-south traffic as an example. And then of course you have active scanning, which is really not as safe as an approach as passive scanning. So my suggestion and what I've seen work well is if you're starting out, obviously getting this site, there's a value there in getting communication, talking with people, building relationships. But if you combine passive traffic analysis and the physical inspection, you'll get accurate asset information kind of pulled together. So I'd recommend that approach, but do what works for you. Beyond that, when you have that encrypted laptop at site, literally cataloging things at the site, this is just a sample of an asset inventory you could use for your organization. And if yes, of course, things like the area of responsibility and who owns the data will come up. Well, we've done many types of asset identification, engagements. And I've seen situations where a substation in the electric sector is being built, and there's a vendor that is not turned that site over to the actual owner yet because they're still building and integrating. So the area of responsibility is key. You can't do, I have not seen successful incident response happen without that kind of the ownership understood. And I have seen situations where you can't get access to devices because you don't yet, quote unquote, own them. They have not been gated yet. So here's an example of that asset inventory. You might want to take attributes of assets, but realize the area of responsibility as you go through as well. Super, super important. So with that, I'm going to pass it over to Stephen just to kind of get his thoughts on ICS visibility, right? From the network perspective or the endpoint perspective. So Stephen, what are your thoughts so far?
Yeah, well, I think it's we know that endpoints in ICS are very, very diverse, they're varied, they're very varied. And it's tough to get any level of visibility on the devices, the physical devices in a consistent manner. That means we need to start with the network. And how do we start with the network? Well, we got to see the traffic. And the two most common ways of doing that are span ports or tap ports. Which do we prefer? Yes, whatever you can make happen. If you can, we want to get the network traffic. I will take any network traffic you can give me. Span has the advantage of not requiring separate hardware, separate expense. As long as your network admin doesn't make any mistakes, there's no interruption to get a span port going. So it has a lot of advantages that way. But there are limits to the number of span ports you can have. They increase CPU load on certain switches, especially. Whereas taps, you have to buy hardware to put in a tap. You have to take an outage to plug the tap in line because it is in line. But taps have the advantage of being able to aggregate data, split data, filter data. So you have a lot more control of the data at source. You could use a single tap across multiple connections, aggregate that all together, send that up to your capture device. So they both, I will take what I can get, but there are some things to consider depending on what your situation is. And I should add as well that when we get down to the field bus level, to the non-IP protocols, it's a different conversation. You may still be able to get something like a span port out of a field bus switch, but we are now having a different conversation at that point. And that traffic, it's interesting to see, it's valuable. It's next on my list. I'd like to see anything that's coming down into that level to have an impact, and I'll worry about level 2 a little bit later. And to Dean's point about the 5-tuple or IP fix or NetFlow, whatever you want to call it, versus full packets, again, we'll take what we can get, right? Any data is better than none. You would be amazed at how much useful information you can get out of IPFix, the 5-tuple NetFlow, far more than you might think. If you are going from 0 to the 5-tuple today, you can keep yourself busy with various use cases just on that 5-tuple. Who's talking to who? You know, trending, are volumes going up, or you know, do you have new dance partners on your network, and so on. IPFix or the 5-tuple is definitely easier to get going. Most switches today support it. There's lots of tools to collect. It's easier, but you know what? Full packet capture isn't that hard either. These days, you know, a laptop from a few years ago with a terabyte of disk and a circular buffer, just keep writing data until you run out of room and start over. You'd be amazed at how much you can get, because a lot of ICS environments aren't that verbose, or there's not that much traffic compared to an IT network anyways. And honestly, you know, I say this sometimes about logging. As a baseline, I'm happy if you're collecting. Yeah, I'd like you to be looking at your data, but I'm happy if you're collecting. So you've got that in a circular buffer, you have the data, you don't even have to be looking in real time, but man, can that full packet capture can be super valuable during incident response when something bad has happened and you can see exactly what it was that happened. All you likely have is the network, so you have to do something. That's I think the point here. But there are other things you can collect though. I would love, this is hard, these, you know, it's coming, but we're not there in ICS environments, but I would love to have full logs of all authentications top to bottom in my ICS network. We're not there yet. We can get that in a Windows world, but that centralized authentication, that kind of logging would be fantastic. As I mentioned, Windows event logs, DNS, people trying to talk to the internet, systems trying to talk across zones in the ICS network. All of those things would also be really useful to see. So that's a lot of stuff. Where do you start? Well, hopefully you have something that looks like a firewall in your environment. Firewalls log data. That's a starting point. That is a log of who is talking to who. You probably have that. Turn on the logging, collect the logging. Firewalls are an opportunity to actually get that packet capture. It's a choke point in your network. Maybe the firewalls can give you a tap port. Maybe you can put something in there. And then after that, we want to start looking at zone boundaries. And like I said, Windows logs at level 3, that's one of the easiest things we can get. So that's a place where we would also like to start.
Awesome points. I think really focusing on the network, there's a lot of value there. I keep going back to the network because usually an adversary has to make it through the network to get to an endpoint. And if we're looking at the Purdue model, if you kind of just like look at it from this perspective, the top part of the Purdue model is traditional operating systems. There could be Windows or Linux. They're OT devices running traditional operating systems. And if you get endpoint data from there, cool, but of that 20%, that's your visibility. If you don't focus on the network, there's like, you know, 70–80% of devices that you don't have visibility on, right? That don't have a way to give you endpoint protection information. So a PLC rack, for example, sometimes, yeah, it can do syslog out to a syslog server, but you don't have that traffic, you know, the communications to and from all of the different components in the engineering level. So again, a lot of value. And I agree with Stephen, starting at the network perspective is a huge win. But now, of course, when you get the visibility, going through the data you're finding is going to be threat detection. There's different ways, of course, to do this, which will render different amounts of false positives, different requirements for tools, different requirements for things like resources. Of course, if we look at the environment kind of threat detection versus the threat component of detection, you can see that down at the bottom right, you can use indicators, which has limited kind of value because you're sweeping the environment. It's kind of point in time, checking to see, have you seen that signature, which can be changed rapidly by the adversaries. So that's the indicators you can kind of scope the environment, looking for the threat specifically using those signatures or indicators. Threat behaviors, those TTPs that Stephen talked about, is the The adversary kicks the doors in IT, jumps from IT using CAS credentials with a shared infrastructure of Active Directory into the ICS, and then from a data historian or something similar, and then pivots to find an HMI. I mean, that behavior is trackable through different hops as well. It's not as simple, of course, as just using an indicator, but the TTPs, threat behaviors, is really going to give you that value of one to many, right? Where you have an indicator, you scope, it's one adversary using one type of malware, and various levels of malware, various versions, for example, but it's usually one campaign in some cases, whereas threat behaviors is really going to give you that ability to proactively change your ICS, protect it before the adversary gets in there. If you look at it from a modeling perspective, there's a huge value in looking at it from an environment modeling perspective. This says, hey, we know that changes exist in the ICS, less than IT. But if you focus on the changes in the ICS that are allowed, and we know that someone updates the time server twice a month, which is odd, but if that's allowed in your environment, cool. If someone updates the time server or the engineering workstation with patches X times more than you expect in N number of days, that modeling, that configuration change over time and over different several times is something that's strange. So that kind of modeling requires additional kind of context, but also possibly tools. But that's a great way to reduce false positives and give you kind of that value. And again, if you only look at the environment for spotting configuration analysis changes, another great way to spot evil, because the adversary has to change something. But then if you look at all the configuration changes, you could see false positives, maybe not. Maybe you're looking at changes that have not been approved, but are legitimate changes as an example. So you could get false positives there. So we are seeing a lot of behavioral kind of tracking using TTPs, indicators still absolutely, but really want to push to modeling wherever you can. Configuration changes over a period of time that you're allowed, anything beyond that threshold, then trigger on. So that could kind of help you. If we pivot to some frequently asked questions on this, pass it back to Stephen. So threat detections FAQs. Stephen, what's your thoughts? What's normal, right? We have this concept of normal. How do you get normal? How do you detect deviations from your baseline?
Well, of course, the answer in today's world is machine learning, because how else would you do it?
Right.
Any product if you look in the commercial world today, machine learning will be the answer. And you know what? Machine learning can be very effective, but it's not our only choice. How else can I create a baseline? Well, you know what? You can do a ton with very, very simple scripting techniques or automation. In the Windows world, it's not hard to come up with a PowerShell script that will collect tasks, services, users, processes, firewall rules, ports, and on and on and on across your Windows environment. You can collect those on a regular basis and look for changes. Even if you're not really collecting them on a regular basis, as long as you have that during an incident, you can go and look and see and collect again and look for differences. Another huge one, this goes back decades for me now, is automatic config backup. And then if you've got an automatic configuration backup, and we're talking all the way down to controllers at the lower levels of the Purdue model, because I got burned by an upgrade at some point where an upgrade changed a configuration in one of my devices, like just the fact of the upgrade. And it was a pain. It took a long time to sort out what was going on. So from that day, I wrote a script the next day that goes out and it grabs my configs every day and it takes a difference and emails me the differences. Something as simple like that. That's a baseline. That's detecting changes. You don't need machine learning to do that sort of thing. Worst case, you should have known good, a gold image sitting on the shelf. Again, you can pull your known good off the shelf and it hasn't been touched. You can compare to that. So abnormal, what counts as abnormal? Well, our ICS environments are pretty static. Yeah, you have to do some tuning to filter out some noise and so on, but because we don't want to drown in the false positives, but the environment should be pretty static. Some really easy things you can do. Clipping levels. I only see this many requests of this type in a day, so let's double that. And if the number goes above some higher threshold, then I want to know about that. Deviation from the norm. What's happened each of the last 30 days? You don't need machine learning to count the number of events or communications of a certain type you get, and look to see if you are, at least a couple standard deviations different from that, or brand new things you've never seen. These are all things you can do without full-on machine learning. So where do I care about this stuff? Well, level 3 is easy and hard because it's Windows. Tooling exists. From that perspective, it's pretty easy to get the data, but there's way more variance compared to the lower levels of the Purdue model. There's more stuff. That makes it harder. So it's, you've got some advantages and disadvantages. Maybe it's just a wash. But the lower levels, they're quieter. There's less change. And so that's, and though when there is a change there, it's important. You want to know about it operationally or from a cybersecurity perspective. So that's a great, we want our baselines from the lower levels. That could be just config changes, as I said, changes to firmware, etc. And I just got to make the point that you have an asset inventory, right? Like you shouldn't be at this point if you don't have that asset inventory, if you don't know what you have. Although again, some of this network visibility can help you build that inventory, but you need to know what it is you're talking to get the baselines from. So again, where do you start? Well, for some of this data is going into a SIM, or you can get it into a SIM. If you have one, that's a great place. As I mentioned, backups. You're doing backups already, hopefully, of some sort. So start looking at them, comparing them, trending them, keeping track of them. Maybe you've got a change control process. There's some clues there when things are changing, and that's an event where you want to go out and look at what's going on. And again, figure out where your environment's static and where you don't want to see changes. It should be fairly easy, and I say that a little bit tongue-in-cheek, to baseline and figure out and go from there.
Awesome. We got some questions coming in. We're going to save the questions to the Q&A section. Please keep the questions coming. A couple in there right on visibility. We'll address those shortly. Want to just pivot to the next component of active cyber defense for ICS, which is incident response. Now, we're probably all very well aware of the IT incident response that does a really amazing job in IT for decades. And so what we've done in ICS is really leverage that, but cater it to it for the ICS specifically. So there are several conditions and considerations that the traditional IT incident response plan just does not account for ICS. Obviously, safety is one of those aspects, unique and legacy systems, of course, as well, the non-traditional operating systems. So as Steve mentioned, how are you going to get logs from a device that doesn't do syslog or doesn't do Windows event logs? So all these things need to be considered. So having a specific SIEM or a SIEM that you can get access to from the lower level devices in the ICS is going to be critical for your incident response process. Also as well, we see in ICS more and more fighting through the actual attack, maintaining safety while you're seeing a threat and kind of doing containment and eradication wherever you can, or maybe you can only do containment and you can't do eradication at that particular time. We've seen threats exist in ICS environments in a contained state for months, depending on the maintenance cycles and depending on what's required to contain and eradicate that malware. So if eradicating the malware means taking the HMI offline or a generating station offline, but in a contained state, if that malware is there, perhaps it can exist there until the next maintenance cycle where you can take the system down, where there's no risk to people, there's no risk to in electric generation, generating electricity for someone in the middle of winter. So there's all these additional considerations that have to kind of go through in the ICS incident response. And 515 really dives deep into those considerations and how to do incident response specifically to ICS across all industrial control sectors. So 515, if you're looking for more ICS kind of incident response, 515 is kind of probably where you want to head to or just consider. So with incident response, a number of different questions, things like, who calls the shots? Who says, hey, there's malware here? Who shuts the system down? Or who says, here's a suggestion to shut the system down? A lot of questions. So I'll pass this back over to Stephen for this one.
Thanks, Dean. I mean, to answer almost all of these questions, there's a really simple answer. Why are you there in the first place? You are there for some sort of industrial process, and that is king, right? So if we talk about the physical or the real world protections, how can they help us? Well, heck, you know what? We've got lots to do. There's lots on our plate to begin with. Our top priorities are health, safety, and environment, and then continued operations or profitability or functionality and so on. That is our focus in IR. If I have real world mitigations, real world protections that allow me to protect health, safety, environment, and continue operations, great. I don't need, well, I shouldn't say I don't need, but it's not as important to worry about those. I can prioritize other things at the cyber level, right? Real world is great. I worked in oil and gas for many, many years. First thing we do in an incident is pile people into trucks and send them driving out to the field, because, you know, we don't know really at that point, but you can, there's a lot of things you can do in the real world to protect yourself. And at the other side of that too is, as if you have an adversary in your network, as you're making changes or trying to combat an adversary, you probably want real eyes on your process as well, because you can't necessarily trust the data that you're seeing. And that theme continues, right? How do we balance containment with operations? As Dean said, you may be running in a compromised state for quite some time. That's possibly okay. You can contain to a point, and you may, you know, we still see configure in ICS environments. You can, if it's not causing harm, or if you understand the harm and can manage it, then maybe that's okay, because maybe you need to wait for a better time to take an outage, either from you know, critical infrastructure perspective or just a profitability perspective. Operations usually wins. It's a cost benefit analysis. It's a conversation, what's more important, and it may not be stopping the attack if I can continue operating. Of course, islanding your control network is an easy option in many cases. Just make sure you know when you're going to do it and how you're going to do it, and what it looks like to operate in that state when you do it. And you may not get to eradication for a while, and that's okay. So guess what? IT isn't calling the shots either. Neither is security, neither is legal. Those folks might have some advisory roles to play, might have a strong influence from corporate risk and that kind of thing, but the decisions are generally made on the OT side, because that's where you have the best understanding of safety, of protection, of health, environment, all of those things. But don't forget in all of that about compliance and regulation, because that can very strongly dictate what you're going to do. So for IR, where do you start? Planning, preparation, which means tabletops, build a plan, test and test and test. Know when you're going to island, how you're going to do it, what the impact of that is. That's probably the first thing, or one of the first things we want to know in an ICS environment. How can I isolate and contain so that I can continue to operate? Of course, inventory, baselining, all the stuff we've already talked about. And having your partners lined up. If you need external help, that could be from vendors, like ICS vendors, integrators, or incident response organizations. And most important in any IR is communication. We could talk for days about just communication. Understand who's who, how you're going to work together, and how you're going to keep on the same page during an IR. And like I said, we could go on forever, but I think that's a pretty good start.
Absolutely. So with the interest of time, just one quick comment on that. Loved how you kind of pointed out tabletops. Love getting people together in a room, engineering staff in a room with ICS security staff, because when there's an incident and you can't get to a site, but your engineering staff is there, you're going to call them and be like, hey, can you pull memory from the HMI? Because I'm still 6 hours away from getting to where you are in the dam in the middle of the woods. So like, those are the kinds of things you really need to have additional staff, not necessarily augmentation, but security roles with engineers to help you with incident response. So love tabletops and making it practical as possible, making sure that your teams are working together to literally pull memory, to literally pull information from the network, give you PCAPs, have PCAPs ready by the time your team gets there to do the analysis. So a lot of value in those tabletops. Now, with the interest of time and more questions rolling in, I just want to say, here's some of the things we can do. You can change the threat or change your environment logically or physically to reduce the ability for an adversary to have an impact. So if you triage the event, you grab malware out of the environment, for example, and you do exploitation of that malware, or excuse me, analysis, you can determine, excuse me, you can determine things like if it's using a C2, well, then you can possibly take that C2, DNS sinkhole it, and then kind of reduce that risk of any kind of remote access or any kind of exfiltration of information. So a lot of things you can do from a logical perspective. Things like islanding, like Stephen mentioned. We're going to talk in a little minute when we do a walkthrough of ICS ACDC about how you can do a cyber safe position, that islanding kind of procedure as well. Offlining the boxes and offlining devices from a physical perspective is not necessarily going to be the end all be all. Safety needs to be number one, but your engineering folk need to be involved in that conversation. The last thing I want anybody on this call to do is, hey, I'm here from security, let's take off, disconnect the cord from the HMI from the internet, and then the HMI is down, you can't run the plant from the plant floor. Like those kinds of things invite you never to get back into the plant again, right? And we don't want to see that. So there's a lot of things you can do. Quick triage of the incident response is going to be helpful for the threat and environment manipulation phase to help you dictate what you can and cannot do. So looking at 10 minutes, I'm just going to give this back over to Stephen for a quick review on this slide. We're going to run you through an actual practical example, and then we're going to get to your questions. So Steve, what do you think? Threat and environment manipulation FAQs.
Yeah, quickly on this front too. What are the common actions? We talked about islanding. That's probably the most common thing that happens. Isolate the ICS environment, continue operations with limited, at least external threat. We want to check for and collect IOCs. That's, in a second, that's a capability we want to have. Can I find that bad process, bad user, whatever it is? We want to make sure that our process is healthy. That is probably number one. And it's funny, every time I do a tabletop, it takes a while to get around to user and account activity. If there's one thing I want to do is look for abnormal logins, accounts being used in ways they're not, or in different locations and so on. It's funny how long it takes us to think to do that, because that's the first thing attackers are doing, is stealing your accounts and moving around. From a capabilities perspective, what do you practice? Again, I've talked about scripts in a few different forms. So start building those now. You can use them for baselining and use them again. I don't care how or what it is, have the ability to both collect information and then act on your assets, whether that's scripts, whether that's vendor management tools, whatever that is. Like I said, collecting and diffing configs and so on. How does threat intel inform us here? Well, that tells us what IOCs to look for, basically. And TTPs will tell us where to look in terms of what assets, what is it, network versus host, where are we going to go hunting for those IOCs? As you might have guessed, there's a hurry up and wait aspect to some of these things. In some respects, the bad guy's been in your network for a long time, or in a lot of cases they have, so there's no rush. We want to we want to walk with purpose is the way I put it. You don't want to wait. You want to get where you're going, but you don't want to cause any more damage while you're at it, especially, but we want to get things done, like things like islanding, things like baselining. You don't want to wait, or baseline comparison. You don't want to wait too long. And of course, ransomware adds that dimension where if you wait too long, the consequences can be severe. So there's certain things like islanding we probably want to do early if we can do it quickly, easily, without impact. But safest actions, collect information. If you have the ability to collect information, watch and learn, that's going to be your safest. And then what's next most safe? Something you have practiced and documented and approved and authorized and all of those things. And finally, higher levels. Again, level 3, you're not going to have as much direct harm or risk to the process. So that's another good place, because that's probably where your attacker has started. So that's another safe zone, if you will, or safer zone.
Awesome. So just got a few minutes left. What we're going to do is run you through a practical example of each part of this cycle very, very quickly over just a couple slides. So practically looking at the active cyber defense cycle for ICS, when you get plugged in to receive, consume your threat intelligence as the first phase. An example here is a publication of Trices that came out. A couple things I want to walk you through. One, we see Yara signatures available. So now you can start scoping memory images or other images, for example, for these specific indicators for Trices. Also, as well, we see on number 2 here, we see that this malware Hatman or Trices is targeting Triconic systems. Going back to your visibility, going back to what assets do you have? Do you have Triconic systems in your network? Are they the vulnerable versions at particularly or being targeted at this particular point? 3 being the vulnerability here, or the attack, is really allowing the adversary to, as you see in number 3, execute arbitrary code in the controller. And also number 4 here is really the safety instrument. The system is, its purpose in life is to protect the process and protect people in the plant. So from this, how can you determine what to look for to do threat detection? So consuming and applying threat intel will get you so far. Then you have to have a mapping really of your inventory. But going from there, looking at your network, this is an example of just having network visibility. Now, yes, this is from a packet payload perspective, going beyond the 5-tuple. But if you have the visibility in your network, this is in the background a capture of the communication to a safety instrumented system, to the Triconics controller, with malicious activity in mind. Quickly, you see here with number 1, it actually is the port that is used for the Triconics controller, which is the 1502, and we see the data going to it in number 2 here as well. So this is the actual communication on the network. Now, without seeing this, it's going to be really difficult to understand if the adversary is in your network. Now, the good news is the adversary had to get in the network to actually execute this attack. That means the communication from the engineering workstation to the PLC has to have been gotten to at some point, which means if you have network visibility, not only can you see this particular attack in motion right here, but you can see the adversary getting to that critical workstation. So a lot of value, again, looking for this type of activity, even if it is just scoping with IOCs around those critical assets we've talked about, right? Data historian, engineering workstation, HMI, and obviously the PLCs at the endpoints. Beyond that, though, you can take your things like YAR rule from your threat intelligence, consumption, reporting, and ingest that and then apply that. This is actually an example of a YAR rule specifically looking for execution and exploitation of Trisis in the Triconics environment inside the ICS. So what we're doing is leveraging the visibility, leveraging the threat intelligence, looking for threats using this. And once you get a hit, and if you find a match, you're going to pivot into incident response. When you know what you're dealing with via threat triage, quick triage, malware analysis as an example, additional scoping, then you can do things that Stephen talked about earlier. This is the ICS Cyber Safe Position. This is actually part of a recent ICS and Network Security Monitoring and IR poster we just released, which is the ICS Safe Cyber Position. Executing these particular steps here can be your islanding process. Once you island, of course, then you can do additional things in your environment to reduce the threats and change the threat or change your ICS, logically or physically. A lot more logically than physical, but it's a lot of things like DNS sinkholing, as we mentioned, or doing things like changing firewall rule access, and also things like kicking certain devices off the network via the switch, etc. So those are some of the things you can do. So very, very quickly, I'm going to pass this over to Stephen. We only have 3 minutes left, but a couple major takeaways we have from here. Stephen, did you want to address any questions on this slide or go right to the takeaways?
I think the big thing is be in a position to get outside help. You're not going to be able to, it's impossible to scale on your own. I think that's, whether that's the vendor or an incident response provider, I think that is the biggest thing, and drive it from the operations side. That's my quick summary.
I think that the external resources for sure can help. My only suggestion is that when you get external resources to help for your ICS, to make sure that they have specific OT or ICS experience. I think as a main takeaway is really the ACDC really excels in ICS defense because it's more static in the ICS. This repeatable process of looking at packets, using tools to look at packets is much more, I guess, achievable inside the industrial control environment. Now, of course, the other main takeaway is having that visibility, right? There's no way you're going to do defense if you don't have a visibility into what assets you have that are being attacked, but also looking at the network itself. So know the assets you have and at least get an understanding of the network visibility first, at least the 5-tuple, and then going from there to your full packet, and then of course pivoting from there into your endpoints where possible. And as Stephen mentioned, ICS specific incident response, prepare, and prepare. Tabletops as an example, include your engineering staff, have the cyber safe position already kind of planned out and work. A lot of value and takeaway from there. The introduction, we do have a blog that Stephen's written, which is the introduction to ICS security blogs. So this is a resource out there for you as well. So please take a look at this URL to read through. I think it's a 3 or 4 part, which he continues to add on to, which is awesome. And one last resource for today before we get to Q&A, if we have time, is the new ICS 418 is open for registration. This is a brand new course. It's a 2-day course specifically for ICS OT management. So managers coming into the industrial control environment to stand up the industrial control security program, or engineers stepping up to the engineering kind of security program. So folks coming from IT, coming from OT, and stepping up to be that manager, person responsible for running a team. The ICS Security Essentials for Managers 418 course might be for you. So we're doing registrations now. The first run is in January 2022. So please take a look there or reach out if you guys have any questions. And it's really all about empowering those security managers at a management level to manage risk and do assessments and understand the risk and managing that risk for industrial sector, which of course is across all of critical infrastructure. Now, I'm not sure that we do have time, but we definitely at least first want to say thank you for joining us for part 3. Part 4 is coming up in December, so please take a look for that, where we'll post later on through social media, etc., the registration information for that one. At this point, I'd like to say thank you and probably pass it back to Carol to see if she has any thoughts and if we can get to any questions or not today.
All right, yes. Well, let's just get to these 2 questions if you guys have a few minutes. The first one says, is the analysis tooling generally better for 5-tuple or for full PCAPs?
It's a great question. Steve, jump in anytime. So there are several tools out there. You can start off with Wireshark with full packet captures to do your analysis and use threat intelligence to drive your search through the packets. So I'm not suggesting get Wireshark and go line by line, but Wireshark is a freely available tool. So if you have network visibility with full packet captures from a span or a tap, you can just use freely available tools like Wireshark to look through those packets. Guided by IOCs from threat intelligence as an example as well. So also you probably have tools available to you already in your firewall as an example to look through the logs and the 5-tuple. So there's several tools out there. Your firewall can probably help given the different types of firewall software that's there, but also Wireshark. Steve, I don't know if you have any other thoughts there, like there's Elk and there's Flowbat and there's a whole bunch of other free tools, but I just go with the basics wherever I can. It's free and cheap and easy.
We were talking about Zeek earlier. Zeek's a great tool that can pull so much information out of full packet capture or full network traffic. And if you have the ability to put a security onion system in place, it doesn't have to be in your ICS, although that can have value, but just having one to parse through data, it automates so much of the work so that you can focus on what was inside those packets. So it takes all the Zeek data, sticks it into Elastic and so on. And there's pre-built dashboards that make it really, really easy to go through. But some of it too depends on what you're trying to accomplish, because if what you're looking for is anomalies, then the 5-tuple is as good as anything to find the anomalies. If you're looking for some of the more detailed information, I'll take full packet capture every day.
Awesome.
All right, thanks. How do you make a distinction between a process anomaly and a cybersecurity event?
So engineering issue versus a threat. Love that. That's an excellent question. We talked earlier about threat detection, behavioral detection. So in general, baselines are definitely going to help, but understanding what happened before that event is going to be critical. So a couple things I'll say. One, your security folks should be inserted into the conversations for root cause analysis for the industrial control environment. So engineering thing goes wrong, there should be somebody from security at the table. How to determine between them though, if it's an issue with the ICS or if it's a security event, it's really all about knowing your environment. Do you expect someone be on the human machine interface and click the lights out button? Do you expect that? Is that a normal thing? Is it against your baseline? So in short, it's really all about knowing your ICS. That means someone in your ICS security team should absolutely have knowledge of the engineering aspects of the system. And visibility will get you that. When you do network security monitoring, you'll understand packet flows, devices that don't normally talk to each other. That is going to be something that's critical to stand out. So I'll pass back over to Stephen, but in general, it's really all about knowing your environment and then popping out the nuanced activities that's possibly strange, and then doing investigation, having network visibility and correlation of events before that change you found. Great question.
I'd just add, the exact same concepts apply to your engineers and operators, because they know their process. They should know what normal is, what normal behavior is, and how anomalies can happen, how that weird thing that just happened, how is that possible? So, and they should also know who's making changes and who's in and out and so on. So exactly the same logic applies to the real world, the process folks as well. Knowing their normal, knowing how that can be impacted, and then going back and figuring out, did anybody actually do anything?
A good point you mentioned again is having the ICS security team and engineering team together, working together, right? Like that's really the value of security in ICS today, with visibility, of course.
All right, well, thank you so much, Dean and Stephen, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.